All right. So let's go through this. We are asked to solve this. And there's a little bit of a clue in the title of these. This is the end of 2.5. There was a question like this on homework 2.5. Which is why we moved 2.5 to be due tomorrow. Because we haven't talked about this one in a minute. So we have done one like it, but not one with quite this funky piece. Because they're calling this a quadratic type equation. What that means is we're going to look real careful and figure out what we can do as a U substitution. Because we're going to do a substitution to make this easier to deal with. And we've done one of these before, and I kind of talked you through kind of the easy way to figure out what our U is going to be. Because what our U is going to be, pretty much every time, I cannot think of a time when it doesn't happen, but our U is going to be that middle term. So we're going to set this up for a U substitution. But I'm going to set my U to be equal to W to the 1/2. Because I really don't want to have to deal with W's and W's to the 1/2. So if I replace any W to the 1/2 with a U, this middle piece becomes 7U, which is way better. We like that way better. This 20 doesn't change. Still going to equal 0. What variable can we put with our 6? U squared. W to the 1/2 when squared would be just W. Exponent laws. So if I take, just thought over here, W to the 1/2 and I square it, what do we do with the powers? Multiply them. 1/2 times 2 would be W to the 1st, right? That's how. So U squared is the same thing as W to the 1/2 squared. This piece I replaced with a U. Substitute it in. See now? If I replace this piece, oh, that's not a highlighter, sorry. If I replace this piece with a U, it's still U squared. It means the same thing. U squared is W to the 1st. Ooh, I have lost several of you. Hang on a second. Do we agree with this piece? Do we see this piece? Okay. And do we see this piece? If W to the 1/2 when squared gives me W, I can substitute in place of that W to the 1/2 the U that we picked. So it's a substitution. Putting the U in place of the W to the 1/2. U squared equals W to the 1st. So I can come over here and say, oh wait, I see a W to the 1st. That's this guy right here. So I can substitute my U squared in place of that W to the 1st. So that we have everything with the same letter, so then it's a quadratic. Better? What's up? However we choose. You can quadratic formula, we can factor, you can complete the square. You've got choices. It does factor. Not super pleasantly, but it does. So we can absolutely factor this when if we do the, like the x, we'd wind up with negative 120 on the top and 7 on the bottom. So our pair of numbers that multiplies to make 120 and adds to be 7 is going to be 15 and negative 8. So you can factor this by grouping. You can throw it through a box. I know a couple of us have a couple other techniques. Factor it how we can, how we need to. We do have an a value, so you need to give me something. Whatever it is you're doing in your head, give me that. Because our factored form is going to be what? 2u plus 5. Okay? This is where we do our factoring. And looking through our work on stuff, there are so many different ways that you guys do this. So we're factoring. I'd say it's split almost evenly between boxing, factoring by grouping, and the magical third one that I don't know and no one shows enough work on for me to figure out what you're doing.
How do you see this?
For which one?
For the last.
I don't know because no one's shown me enough work for me to figure out what's happening yet. As far as I'm aware, the people that can go straight from here to here, even without this, are wizards. I have no idea what you're doing. I was going to say, at some point you'll need to talk me through it so I can show you, so I can do but I have genuinely no idea what is happening in your brain between the top one and the bottom one. I have not a clue. I've never seen it that way, so show me. I'm happy to learn it. But as far as I'm aware, it's wizardry. I know y'all don't know me quite that well, but I would 100% love to learn some real magic. Come on, I got the magic wand. You got a pen? Okay, so show me your wizard ways. I would be happy to learn. But there are at least 3 different ways that people use in here. So let's get our solutions here. We have what as our solutions? Watch your sign. 4/3. And u equals -5/2. Right? Once we get it into factored form, you set each factor equal to 0. We were asked to solve, which means we need to get to our variable equals. Right now we're at a u equals, not a w equals. Ma'am, keep your life together. Thank you. So we need to substitute it back in. We've got to get back to our w. So our u's down here really stand for w to the 1/2 equals 4/3, and w to the 1/2 equals -5/2. Yeah, that was my next question, was what do we do to get w by itself? Square it, because to the power of 1/2 really means what? Square root. So this is square root of w equals 4/3, and square root of w equals -5/2. So we're going to square both sides. So w equals 16/9, and w equals 25/4. We should check them. We should check them. I'll tell you, I was like, one of them is extraneous. We'd have to substitute it in. And it's the one that we squared that was negative. So when we're doing these U-type substitutions, sometimes we can spot when, if we went backwards, our answers would change. If we had a w of 25/4 and we worked backwards to get our square root, I would not wind up with the exact same answer here. This one will wind up being extraneous, and you can find it by substituting in or noticing the fact that, oh, if I square rooted this, we won't necessarily pick the negative. to get back here. So it's not going to be a major thing. We're not going to typically have that kind of issue going on there. I was like, yeah, without a calculator, it's obnoxious. The people who wrote the textbook expected you to be able to use calculators, but IU says not to. So when we give you the things that we write to expect you to do it without a calculator, it'll be doable. The book is a pest. Okay? So, and this one came from the book. It was an example from the book. I believe it was the homework question above the one in the homework. The one in the homework is definitely doable without the calculator. So this one is extraneous. And I'm telling you that it's because if I was to work backwards and solve it this way, we wouldn't usually take the negative on the square root part here. Yes?
Let's say you had a question like that, and we don't simplify it all the way down to like W equals, and we don't have to.
Like, so if we get to the W equals part and we don't get a chance to check, we're fine. Okay? I still want us to check, but like it would not be like a no points situation. Okay? If we forget to switch back to the W and we leave it here at the U, then we got a problem. We're not done. We did not finish the problem. So that would be at least a point off. Okay? So we've got to make sure we're checking if we've got the time. I'd rather us finish solving all the things than be stuck on checking stuff. Because it's, again, it's not going to be a major thing. Usually we're a lot nicer about it. So the one in the homework is a lot more like this one. I'm looking at that one. So we're going to do one more like this, and this will be the end of 2-5. Okay. So we're going to do this one the very same way. We're setting up a U substitution. So I'm going to pick my U to be my middle term. It's always going to be whatever this variable is. Yes, dear?
How do we like when do we know to use
If I see a 2 and a 1 here, or on the last one how we had, this one was 1/2 and this one's doubled to be 1. So if I have a single term here and a doubled of that term here, or we have a single and a doubled, more often than not, we will say something like solve this quadratic type equation, and that's a big old clue right there. So if it says solve this quadratic type, substitute in so it looks like a quadratic. So our U we picked to be that middle term, because that should be the single version. So our U is going to be x to the 1/3, and that's not a pen. X to the 1/3. So when we're substituting in, we're going to have 3U squared, because x to the 1/3, 1 squared gives me x to the 2/3. Plus 4U minus 4 equals 0. All right, this one will also factor. You can use whatever technique. This one becomes significant, like it's not super gross. Yes, dear. Because x to the 1/3, and we're trying to get it to be x to the 2/3. So if it helps to do it this way, we can think of, okay, I got my U is going to be x to the 1/3. X to the 1/3 times what gets me x to the 2/3. Okay, so it's either x to the 1/3 times x to the 1/3, which means x to the 2/3, or x to the 1/3 squared. Okay, so whatever it is to get from my piece for U to my piece on my first term is what we're trying to do. Yes, Jim?
You said multiply 1/3 by 1/3.
I was like, not multiplying 1/3 by 1/3. When we multiply, we good over there, guys? When we multiply our bases, we add the exponents. Okay, so x to the 1/3 times x to the 1/3, that is the same thing as x to the 1/3 squared. So you can think of it as adding our exponents here to get this, multiplying our exponents here also gives us this. This is two different ways to write it. And it's just going to be a matter of finding how it works for your brain. And noticing that this piece is the same as this piece. And that this piece is the same as this piece. Okay, so I've written it in two different ways here. And whichever way your brain goes is how we're going to do it. So we need to factor this or solve it in some way, shape, or form. It does factor. So if you use this way, we have our -12, our +4, and our two numbers are going to be 6 and -2. So our factored form, when you factor it, box it, factor by grouping, or wizardry, our factored form is going to be what?
3u minus 2u plus 2.
And u plus 2.
It's so easy, just do it in your head.
I just don't know what you're doing in your head. All right. So what are our solutions?
X, a over 20, oh no, sorry.
Yep, u equals 2/3 and u equals -2. So, but I don't want to stop at a u equals, I need to get back to my x. So my x to the power of 1/3 equals 2/3. And my x to the power of 1/3 equals -2.
So now you cube it.
What do we do to get our x by itself?
Cube.
Cube it. To the 1/3 means take the cube root of. So to undo that, we cube both sides.
8 over 27 and then
Yeah.
-8.
So we're cubing both sides to get 8 over 27. And cubing this side to get x equals -8.
Is it extremely?
They are both valid. Cubing both sides, 2 cubed is 8, 3 cubed is 27. Okay? Good question, good question. Questions on this? This is the last thing in 2.5, and I know there's several questions like that on the homework, which is why we pushed that homework back a bit. Okay? Questions on that one? Because that gets us to finally finish 2.5. I just didn't want to try and speed run those. Okay? So now we're going to start 2.6, which changes. Different thing. We're going to look at inequalities. 2.4, 2.5.
Oh, thank you, because I don't want to do 2 songs. Oh, it's going to be on the test.
This will be on the test. Okay.
Yeah, we have the test.
Chapter test is next week.
Tuesday, right?
Next Friday.
But he's trying to do it.
I was going to say, because here's today. Chapter test. Friday. Next Friday. What's up? We do have a quiz tomorrow. What's up? For the test, absolutely. And I will have the study guide tomorrow for you guys and then make copies of them. I always try and get you guys the study guide for the test the weekend before because I know some of us need that time on the weekend to do it and weekdays get busy. So I have this little table. If you want to draw your own, that's fine, but I did print them out for you guys so you didn't have to try and draw the table. Because we're going to go through inequalities and writing it in interval notation. Because because we're going to deal with inequalities, and inequalities are going to come up fairly frequently in the next unit as well. So what we're going to do is we're kind of going to do this as a general, how we can write an inequality in interval notation, and I'm going to sketch them on a number line too. If those help you, great. If they don't help you, don't worry about it. Okay, because what we're doing here is we're basically just trying to remember. So if I have the inequality of A is less than X, which is less than B, and we're trying to describe X as an interval, I'm going to think it out on my number line over here on a sketch. My X has to be bigger than A, and it cannot be equal to, so it would be an open circle, right? So that would be A. And B will also be an open circle, right? And X is somewhere in between. Like this, right? Do we see that part? Yes.
So if it doesn't have a line under it, it's open. If
Oh.
it does, it's closed.
Correct. Yes.
And close is what it's equal to.
Correct. So I'm going to make a little note at the top. So our open circle goes with our less thans or our greater thans. And when we're doing it in interval notation, that's the thing that goes with our parentheses. So the interval is going to be from my smallest piece, which is A, to my biggest piece, which is B. And both of them are open, so they both get parentheses.
Oh, I like this actually.
And it's going to be very important. Every time we write domain and range in this course, we're going to be using interval notation. So it's super duper important. Huh?
Are we doing that second semester?
Nope. Next chapter, we will be graphing a whole bunch of stuff and finding domain and range on a whole bunch of stuff. We're going to need interval notation on a whole bunch of stuff. Parentheses are not equals to. Sorry, those are like almost touching up there. I'm going to fix these. These were meant to be parentheses, not a single circle. That is not an arrow. For our closed circles, that goes with our equals to, and that's when we use, I already heard it said once, our square brackets. So if we're looking at our next one, which is very, very similar, my X is between the A and the B, but now my A is closed, and my B is also closed, and we are in between. We're going to write our interval as A as our smallest, B as our biggest, and since both are closed, they both get square brackets. Our interval always goes smallest on the left, biggest on the right. It's very similar to an ordered pair. Order is important too. Smallest to biggest. Questions on those two? Our next four are very, very similar. Both are just single terms. So my X has to be less than or equal to A. So since it's an equals to, we're going to have a closed circle. And when it's less than, it's going that way. So when we do our interval notation, we do our smallest to biggest. What is the smallest my x's can be? Negative infinity. This goes from negative infinity to A. Can it equal A? Yes, so we put it in a square bracket. Can it equal negative infinity?
No.
No, infinity is an idea, not a number. I cannot have something equal infinity. So we use a parenthesis because infinity is an idea. The next one's very, very similar. X has to be less than a. This time it's not less than equals to, it's just less than. Infinity deserves what? Yeah, it is, but it is still an idea. It's a concept. All right, so now we're going less than a. So what is going to be different on this interval than the last one?
The brackets don't be.
It's an open circle, and that means we're going to have a parenthesis instead of a bracket. So it's negative infinity, the farthest left it'll go, to a, but it cannot equal a, it just gets real, real close. All right, so we're going to finish these out. I'm going to have to go back through my color cycle again. Very, very similar on our next two. My x has to be greater than or equal to b. So now I'm going to have b here, and x is greater. So it's over here, and it's equal to, so I need to color in my dot. So how are we going to write this as an interval? From b to infinity. Does the b get a bracket or a parenthesis? Bracket. Does the infinity get a bracket or parenthesis? Parenthesis. Never, ever, ever put a bracket on infinity. Yes. It is wrong if you put a bracket on infinity because we cannot equal infinity. Infinity is an idea, not a number. Very similar on the next one to what happened with the A1. Because it's just that it switched from equals to not equals to. So I'm still going to wind up with my B. And that my x is greater. This time on my interval, we're going to have a parenthesis on the B. Spending this much time on our interval notation. This is one of those things that's very, very important. We're going to use bunches and bunches and bunches. Two more. So now I've got another split one, kind of like at the top, where I have green. That A is smaller than X, which is smaller than, which is less than or equal to B. So it's everything between A and B. So putting this in our interval notation, what are we going to have? So A is going to have which one? Parentheses or bracket? Parentheses. And the B is going to have a bracket. So we're going to have wonky ones where they have some of each. And the last one is going where X is between negative infinity and positive infinity.
It could be anywhere.
So it could be anywhere. There's nothing limiting it. In the whole existence of numbers. Well, technically real numbers right here, but still. So our interval notation is going to go from negative infinity to positive infinity.
Yay.
And you can absolutely write it like that. Sometimes in the book they will also write it as this, all real numbers. So you can use either one, but I'm going to use the interval notation for things. And we're going to practice and solve inequalities to get answers and write them as our interval notation. Cool. Questions on the giant table of stuff? Okay, because where we're going to use this to start is on things like this. We're going to start solving inequalities. Cool. There's a couple things we have to be careful of with inequalities, and we'll point those out as we get closer. Why not? What's our instinct on this one? Subtract 8. We can absolutely subtract to both sides of an inequality. We treat it like an equation for the most part. There's only a couple times things go wonky. Bless you guys. It's sneezy in here today. So we're going to have our 3x is less than negative 1.
That's true.
Now what can I do to get x by itself? Divide by 3. Do we flip the sign? When do we flip the sign? When you multiply or divide by a negative number. So this one's fine, it's positive. So we're going to have x is less than negative 1/3. That's our solution. We're going to write it in our interval notation. I'm going to sketch it out so we can see. I can just label my point here, negative 1/3. Am I going to be an open circle or a closed circle? Open circle. And are we going to color to the left or to the right of my 1/3? Left, because x is smaller, less than. So our interval, negative infinity to negative 1/3. Infinity always gets a parenthesis. Is our negative 1/3 getting a parenthesis or a bracket? Parenthesis. Okay? And we know how it goes. The first couple are going to be not too bad. I do not recall if I put in the instructions to draw the number line. When we get into graphing things with these inequalities, we're going to draw the number line because it really helps us keep track of stuff. So at this point, you don't have to draw the number line, but when we get into polynomials with inequalities, we are going to want to draw it because it helps us see when it's in weird places or between. Okay. Well, let's look at the next one, and you have a couple of options. You can power through with the fractions, absolutely fine. We can also look at this and go, ew, I hate fractions. How can we get rid of fractions? Multiply everybody by their denominators. Yeah, you can either do it as our least common denominator and do it as 1, or you can do by all the denominators we see and do it in pieces. So I would really like to get rid of my 5 that's in my denominator there. So if I multiply absolutely every single piece by 5, that's going to get rid of this denominator over here. Cancels him out. I would really also like to get rid of this denominator here. So I'm going to also multiply everything by 3. And you can do it in one step like this. I'm okay with that. You could also multiply everybody by 15. Totally fine. I'm just trying to save it so we don't have to rewrite 1.5 billion times. I've multiplied everything by only positive numbers, so I don't need to change my sign. So it's going to give us 3x, because that's the only piece left on this guy. 4 times 5 times 3 gives us what? What is 4 times 5 times 3? 60. When in doubt, do your 4 times 3, giving you 12 times 5. We know that. We can put it in whatever order we want. Greater than or equal to 5x minus 7 times 5 times 3. I heard it. It was quiet, but it was there, 105. So you can do it with the fractions, or you can do this and get rid of all your fractions, or you can do some combination therein. It doesn't really matter. Whatever makes it easier for you to do. So now what should we do? Subtract the 3x. If we move our smallest x, it will give us the least amount of negatives we can deal with. Because then our x shouldn't be negative if we move the smallest piece. You don't have to, but it makes it so you don't have as many negatives to deal with. So we're going to have 60 greater than or equal to 2x minus 105. And what should we do? Add the 105. So we have our, what's on the left-hand side? 165 is greater than or equal to 2x. So 165 over 2 is greater than or equal to x. Divide both sides by 2. Was that? Did we divide or multiply by a negative? Okay, so it's only if we multiply or divide by a negative number. I multiplied by positive numbers and then I divided by a positive number. And if you always move your smallest x, you won't have to worry about that too much. If you always move the smallest one, you shouldn't wind up with negatives, your x to divide by. So we need to write this in our interval notation, and it does sometimes help to sketch your number line. We don't have to simplify the fraction. It doesn't particularly matter what that number is. This is, I can just call it 165 over 2. Is my dot going to be filled in or open? Filled in. Are we going to go to the left or to the right?
Because it's a negative.
X is smaller. Which one's smaller? X is smaller. Watch that sign. If they are on the opposite side than you're used to, make sure you're paying attention to that, okay? So our interval is going to go from negative infinity to our 165 over 2. Negative infinity has a parenthesis. 165 over 2 has a bracket.
That's our solution.
That's our solution.
This is the last question.
Okay? That's our solution here. Because we're looking for those intervals. We only have 3 minutes left. So we'll call it good. And we'll finish it like we're gonna work with them more tomorrow. Like, don't be that excited. Just saying. The rest of this unit is inequalities. And so homework 2.5 is due tomorrow. 2.6, which is what we just started, is due on Wednesday. We don't have school Monday because Monday's Labor Day. So I will get you guys the chapter review tomorrow. I'll have copies of it. We do also have quiz tomorrow. So look at that. I know. Horrible.
Yeah, it looks like that.
What's up? Chapter test is over all 22. It's a unit test. There we go. What's up?
I love this homework.
Like, in order for me to show you how to do work, you're going to show me what you're doing. Okay? Correct. Chapters 1 and 2, unit 1.
What I do, no, statement. Like statement.
I mean, you don't have to. I don't think it'll make it easier.
Thanks, back to you. Have you done one? All the answer keys for these ones should be posted up on Canvas, so you can check everything.
I bet Aaron can do otters.
Right?
I got it because I am.
No,
What do you got if you were like you're reading? Oh, well. I'm just gonna say that.
Right.
Tell that you got it.
Well, I don't do like the whole thing. Like,
It's actually really cool. We're not.
Okay. Yeah, it is a guess and check. It makes it harder on things like these ones where we have the tutors.
Wait, why is this
We
pen?
have like 3 and 2. So there's a lot of guesses. What if it was 6 and 1? 3 and 2. What if that was 1?
Oh, that's the thing. I don't know where the answers were.
3 or 4. Lots of points. So that works as long as you don't mind. It could take forever to find those factors.
Yeah, I try to.
Yeah. Right. Yeah. It's just kind of guess and check. Okay, I can work with that. Okay. Just be careful because it might take you way longer to figure those things out. So, iPad. I don't think it's up the recording. Woo. Sneak.